All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we will continue our discussion of congruent triangles by learning how to classify triangles using their side lengths without a graph. So we don't have a graph and we just have the coordinates of the vertices of the triangle. And what we're going to have to do here is use the distance formula. Okay, so if that is something that escapes your memory, the distance formula, d equals the square root of the square difference in the y values plus the square difference in the x values. So what that looks like is open parentheses y2 minus y1 close parentheses squared plus open parentheses x2 minus x1 close parentheses squared. Okay, so this is the distance formula. I'm going to write it again up here so we can refer to it as we go through these problems. So the distance formula, where the distance is d, is equal to the square root of the sum of the square differences of the x and y values. So that's the square root of the sum of the square differences in the x and y values. So that's y2 minus y1 squared plus x2 minus x1 squared, all underneath the radical sign. So down here, we're looking at a triangle, but it's not given to us in a graph. For the purposes of demonstration on number 21, I'm going to show you what is happening visually, but we won't do that for 22, 23, and 24. Let's plot these points here in 21. Now you can just watch this if you want. So J is located at -7, -7. So that's -7 on the X and -7 on the Y, right there. Okay, that's point J. Point K is located at -9, 1. So that's over here, -9 on the X, 1 on the Y. That's point K. And point L is located at -1, -1, right here. This is point L. Okay, so if we connect these dots, we will see a triangle form. Okay, and we have to figure out what the lengths are here. We have to figure out the length between J and K, the length between K and L, and the length between J and L. And we have to analyze them using the rules that we learned about classifying triangles, which we'll go over. But in order to find these distances, we have to apply the distance formula. So, going back to our work surface here, we're first going to find the distance between J and K. So we're actually going to find a segment distance, JK, and that is going to be equal to the square root of the differences, of the sum of the square differences of the x and y values for points J and K. So on your end, what you need to write is JK with a line over it to indicate segment distance equals, and then a big square root sign. We might even have to extend it out farther. So I'm going to do an open parentheses, and here I'm going to be looking for the y2 value. So I'm looking for the y value of point K. So that y2 value would be 1. Okay, 1 minus. And now I'm looking for the y value of j, because this would be the y1 value. So it's 1 minus negative 7. y2 minus y1. Close parentheses, squared. Plus, now I have to find the squared difference between the x values for j and k. So I'm going to start off with x2, which would be the x value for the k coordinate. And that would be negative 9. Negative 9 minus the x value for the j coordinate, which would be negative 9 minus negative 7. Okay, close parentheses, squared. The most important thing is that you're able to set this up. Okay, so we're going to do another simplification here. I can connect these two negative signs and turn them positive. Okay, because a negative and a negative makes a positive. And now I can proceed to the next step of simplification by putting an equal sign to the right and drawing another radical symbol. This one doesn't need to be quite as long. Now what I'm going to do is follow my order of operations and add up these two things here and square it. And then add up these two things here and square that. So 1 plus 7 is 8, and 8 squared is 64. 8 times 8 is 64. So I'll write 64 plus, and now I have negative 9 plus 7. Negative 9 plus 7 is negative 2, and negative 2 squared is positive 4. Negative 2 times negative 2 is positive 4. So I have 4. Now all I have to do is finish adding 64 plus 4 underneath the radical sign, and I get a new simplification, square root 68. And that's all the further we need to go. We don't need to approximate this or simplify it any further, because all we're going to be doing with this value is comparing it to the other two legs of the triangle. So what do we know now visually? We know that the distance between j and k is the square root of 68. Well, now we have to find the other two distances. Well, now we'll find the distance between k and l. K, L, line over it, equals. Big square root sign. Try to keep these the same length. And if you haven't already, please make sure you're using a straight edge to do this, because the human hand is just not good at drawing these big lines. Okay, so now we have to figure out what the y2 value would be in segment KL. Well, it would be the y value of the L coordinate, which would be negative 1. So I'll put negative 1 minus the y value of the k coordinate, which is 1. Negative 1 minus 1. And all of that is squared, plus, in open parentheses. Now I need to do the same thing for the x values. First I'm looking at the x value of the L coordinate, that's x2, negative 1, minus the x value of the k coordinate, which is negative 9. So be very careful with your negative symbols because they're stacking up here. and all that's squared. Okay, so our next step will be to simplify this double negative here. A negative and a negative makes a positive, so we connect these two and make that a plus sign. Right? And now our next step is just to simplify what's inside the parentheses and then square that result and write those products here. So negative 1 minus 1 is negative 2. And negative 2 squared is positive 4. So I'll write that here. Plus negative 1 plus 9 is positive 8. And positive 8 squared is 64. So I'll write that here. Okay. Now I'll write an equal sign and further simplify by adding those two elements underneath the radical sign together. 4 plus 64 is 68. So this side length, KL, is also 68. So now I know that JK is square root 68 and KL is square root 68. All that's left is for us to find JL. Okay, so we'll write JL. Okay, so write that JL with a line over it. Segment JL equals the square root symbol, open parentheses, and now what I'm looking for is the y value of coordinate L, and that's negative 1. Negative 1 minus the y value of coordinate J. So negative 1 minus negative 7. Close parentheses, squared, plus open parentheses. And now I need the x value of point L, which is negative 1, minus the x value of coordinate J, which is negative 7. Close parentheses, squared. So in both of these elements, I have double negatives, and I can connect those to make them positive. So that's what I'll do. Make them positive and make them positive. And I'll now simplify by setting this equal to another square root symbol, another radical sign. And what I'm going to do is add the elements of the parentheses together and then square that result and write that result here. So negative 1 plus 7 is positive 6. Negative 1 plus 7 is positive 6, and positive 6 squared is 36. Plus, and now I have negative 1 plus 7 is positive 6, and positive 6 squared is 36. And I can simplify that further by adding these two elements of the radicand. The radicand is what's underneath the radical sign. So radicand, radicand, 36 plus 36 gives me the square root of 72. Okay, so we now have all of the segment lengths. Let me just, for this one alone, I'm going to write them on this graph. JK is square root 68. KL is square root 68. And JL is square root 72. Okay, so from the perspective of analyzing the sides, we have two side lengths that are the same. And if we review our definitions from the other side of this page, if I have two congruent sides, I have an isosceles triangle. Right? So just by analyzing these side lengths even without the picture, I can determine that this is an isosceles triangle. What I can't tell you is what it is in terms of its angles, but I can tell you what it is in terms of its sides, isosceles, which is spelled ISOSCELES. Okay? Now, for the remainder of these problems, I don't think I'm going to do numbers 23 and 24 because we'll run out of time. But number 22, I'm going to demonstrate without as much commentary. I'm just going to do it as quickly as I can so we can analyze its results. Okay, so we know we're going to have to find segment distance JK. Okay, we know we're going to have to find segment distance KL. And we know we're going to have to find segment distance JL. So we have to find these three segment distances. And they're all going to follow the same pattern. So for JK, we'll have the square root. Okay, and now I'm going to look for the y value of the k coordinate, 6, minus the y value of the j coordinate, 2, squared, plus the x value of the k coordinate, 2, minus the x value of the j coordinate, -3, squared. I can connect this double negative, make that a positive, and we'll simplify this further on the next square root. 6 minus 2 is 4, and 4 squared is 16. 2 plus 3 is 5, and 5 squared is 25. (16 plus 25 is 41, so this can be simplified to the square root of 41. For segment KL, set this up, same basic framework. First, I'm going to look for the y value of the L coordinate, -1, minus the y value of the k coordinate, 6, and square that, plus the x value of the L coordinate, 8, minus the x value of the k coordinate, 2. And I'll square that. Okay, so no double negatives to deal with in this problem. But we'll further simplify. -1 minus 6 is -7, and -7 squared is +49, plus 8 minus 2 is 6, and 6 times 6 is 36, so 6 squared is +36. Okay, so now we have to add 49 and 36. So I'm bad about doing this in my head, so off to the side, you might be better, but off to the side I'll do it on paper. 49 plus 36. 9 plus 6 is 5. Carry the 1. And 4 plus 3 is 7, plus 1 is 8. So we have 85. So this simplifies to the square root of 85. And now on to JL. We have the same setup. I'm looking for the y value of the L coordinate, -1, minus the y value of the j coordinate, +2, squared, plus, open parentheses. Now I'm looking for the x value of the L coordinate, which is 8, minus the x value of the j coordinate, which is -3, squared. Here I have a double negative to take care of. Put that together, make it a positive, equals, okay, square root. -1 minus 2 is -3, and -3 squared is +9. 8 plus 3 is 11, and 11 squared is 121. Okay, 121 plus 9 is 130, so this simplifies to the square root of 130. Okay, so now let's do our analysis. We have 3 side lengths, square root 41, square root 85, square root 130. None of them are the same. So if we go back to our chart, by sides, we have no congruent side lengths, so this is a scalene triangle. Scalene triangle. S-C-A-L-E-N-E. Scalene. Okay? Now, with that information, you have all of the information or all of the instruction that you would need to complete problems 1 through 15 in your homework. Okay? So, we won't do numbers 23 and 24 because it's just more of the same thing. If you want to do those, you can. But now let's flip the packet and let's take a look at number 1 on this page, solving for sides with algebra. And I think I misspoke just a moment ago. What you're able to do with what we've learned so far are numbers 1 through 11 on the homework. But numbers 12 through 15 will be covered right here. So again, we're solving for sides. So this is not an angle analysis. This is a side analysis. Here's what we're given. If ABC is an equilateral triangle, solve for both x and y. Okay, well, what that means is that this side and this side and this side are all congruent. Okay? So what we can do, and this m here is not a variable, it's a distance. It's like 45 meters. So if that's confusing, just consider this to be 49. This is 3x plus 1, and this is 18y minus 41. So because these are all congruent, we can just set one or the other sides equal to one another to find out what that variable is equal to, because that's what it wants. It wants to know what the variable is equal to. So let's set segment AC equal to segment AB. Okay? So that's 18y minus 41 equals 49. So that's how we're going to solve for the y variable. Now to solve for the x variable, we'll set BC equal to AB. So over here, we'll set 3x plus 1 equal to 49. Okay, so we have two different math problems to solve right here. Okay, so let's get y by itself. First, we will add the constant to both sides, 41. We'll add 41 to both sides. On the left side, negative 41 plus 41, those cancel out, and that's 0. And so we have 18y equals 49 plus 41, which is 90. Okay? And now we divide both sides by 18. And 90 divided by 18 is something that we're going to have to do. All right? I don't know how many times 18 goes into 90 off the top of my head, but one thing that I can do very easily is factor the numerator and the denominator. Okay, so what I'm going to do is move up here into side work here and show you what I'm talking about. When you don't know how to divide two numbers, but those numbers have factors in common, what you can do if you don't have a calculator is you can factor both the numerator and the denominator. All right, so think about 90. Well, that's 9 times 10. Okay, well 9 is 3 times 3, so it's 3 times 3, and then 10 can be written as 2 times 5. So that's 9 times 2 times 5. So I've prime factored the numerator. Now I'll prime factor the denominator. We know 18 is 6 times 3. So we'll put the 3 there because that's a prime number. But 6 isn't prime. We have to do 3 times 2. So it's 3 times 3 times 2. That's 18. 3 times 3 is 9, 9 times 2 is 18. And now what you can do is cancel out all the numbers in common on the numerator and denominator. So that would be 3 and 3, cancel. 3 and 3, cancel. 2 and 2, cancel. The only number left is 5. So 90 divided by 18 is 5. These 18s cancel and you get y equals 5. Put that in a box. Now over here we have to solve for x. So first thing we'll do is get x by itself. And to do that, we have to subtract 1 from both sides. One minus 1 is 0. So I have 3x equals, and 49 minus 1 is 48. 3x equals 48. Okay, this one's relatively straightforward. You divide both sides by 3 now. These 3's cancel, leaving x by itself. And 48 divided by 3 is 16. Again, if you didn't know that, up here we have 48 over 3. Okay. Now think of two numbers that multiply to be 48, like 6 times 8, right? Well, instead of writing 6 times 8 in the numerator, you would write 3 times 2, which is 6, and then 8 is 2 times 2 times 2. So times 2 times 2 times 2. And down here in the bottom, you'll write a 3. And the only thing that cancels up here are the 3's. So now you just have to multiply. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this reduces down to 16. So that means 48 divided by 3 is 16. Okay, so x equals 16. Okay, now I'm going to skip number 2, and I'm going to skip number 3 because we've looked at equilateral triangle already. I want to jump down here to number 4. Number 4 presents us with a challenge. If triangle DEF is an isosceles triangle with segment DE congruent, that's what this symbol means, congruent to segment EF, find x and then find the measure of each side. Okay, so first we find x and then we plug x back in, find the measure of each side. So these two sides are congruent. And that's the key, right? So we're going to set these, because they equal one another, we're going to set them equal to each other and solve for x. 8x minus 13 equals 5x plus 17. Okay? And so we're just trying to get x by itself. Our first step, I mean, you could open this chess move in either way, but I'm going to subtract 5x from both sides. I'm going to group my x's together. And again, it's entirely up to you. You could have dealt with the whole numbers first. We're dealing with the x's. So on the right side, 5x minus 5x is 0. And on the left side, 8x minus 5x is 3x. Just bring everything down. 3x minus 13 equals 17. Okay, all we have to do now is add 13 to both sides and divide everything by 3. So we'll now add 13 to both sides. Negative 13 plus 13 is 0. Okay, so I have 3x equals 17 plus 13. Well, 7 plus 3 is 10. Carry the 1. 1 plus 1 plus 1 is 30, or 3, so it's 30. 3x equals 30. So now divide both sides by 3. The 3's cancel on the left, and I get x equals 30 divided by 3, which is 10. 30 thirds is 10. But that's not what the question asked for. The question asked for the measure of each side. So now I've got to plug in 10 everywhere I see an x and solve it out. So here I'll write 8 times 10 minus 13. Okay, remember we're going to have to do this multiplication first. And we'll see what that equals. 8 times 10 is 80, and 80 minus 13 is 67. Okay, so we'll put 67 here. For my next leg, I know it should be identical, but I'm going to check it anyway. I have 5 times 10, 5x, 5 times 10, plus 17. Okay, so 5 times 10 is 50, plus 17. 50 plus 17, that's also 67. And that's what we expected to happen. We expected those to be congruent. If they hadn't been, we'd have done something wrong. Finally, we've got to find df. That's x plus 21. Well, x is 10, so it's just 10 plus 21. And 10 plus 21 equals 31. Okay, so these are the side lengths. This is what they want to see. And I'm betting they want you to label them. So this is DE, and this is EF, and this is DF. Okay? Now, number 5 is solved just like number 4, so we'll skip it. Okay, number 6 and 6 is just like the ones we already did, but I see here that numbers 6, 7, 8, 9, and 10 don't have triangles, so we have to work without a picture here. Okay, fair enough. We'll do number 6, and then we'll call it a day on that. Yep. So number 6 will be the last problem that we do, and number 7, 8, 9, and 10, pretty self-explanatory once you get the idea of what we're doing here. So we have a triangle P, Q, and R. It's equilateral. Okay? It's equilateral. If you ever want to know how to construct an equilateral triangle, it's pretty easy. We'll just draw a line segment like this, and then you take a compass, right? Take a compass, and we'll stick a pencil in there. This is pretty cool. And you're just going to set your compass length to the length of that segment, right? Now rotate an angle like this, and then flip where your pointy end is over to the other side, and rotate an angle like this. See that? Now this point right here, this point right here, and this point right here form the vertices of an equilateral triangle. That was pretty neat. Okay. So just so we can have a visual reference, we've got our equilateral triangle right there. Can erase your scratch work. If you don't have a compass yet, get one. Okay, so we can label these P, Q, and R. And we'll label the sides. PQ has a length of 18x plus 1. So this is 18x plus 1. QR has a length of 24x minus 17. QR, 24x minus 17. And PR has a length of 15x plus 10. Okay, so I can, because it's an equilateral triangle, all these are equal to one another. They're congruent. So I can just set the two of the equations equal to one another and find x, and then plug x in and find the length of, once I find the length of one side, I know the length of all the sides. So let's just set 18x plus 1, trying to choose easier equations, equal to 15x plus 10. Right? And all I'm doing is solving for x first. So first thing I'm going to do is subtract 15x from both sides. $15x minus 15x is 0. 18x minus 15x is 3x. Bring everything down. 3x plus 1 equals 10. So now I'll subtract 1 from both sides. 1 minus 1 is 0. So now I have 3x equals 10 minus 1, which is 9. So if 3x equals 9, x equals 3. We're going to divide both sides by 3. Okay, and we get x equals 3. Well, if x equals 3, then I can plug it back into any one of my points or my segment lengths and figure out the length of all the sides. So I'll do here PR, okay, which is equal to 15 times 3 plus 10. Well, 15 times 3 is 45, and 45 plus 10 is 55. So that means that all the side lengths are 55. You got PR is 55. You've got QR is 55. And you've got PQ as 55 because they're equilateral triangle. And that's the answer to that problem right there. Okay. Now, we are hitting the 41-minute mark, but I do feel like I need to at least explain how to read these problems so you can convert this into math language. So, because this is going to come up on the homework, I want you to be able to see this. ST. We got to figure out ST here. We know it's an equilateral triangle. That's important. ST is 1 less than twice x. Okay, so that means ST is 2x minus 1. SU is 37 less than 5x. Okay, so SU is equal to 5x minus 37. And TU is 11 more than x. So TU would be equal to x plus 11. That's how you figure those out, all right? On your homework, see where that went. Let's see on your homework if there was any that you have to do like that. Okay. On your homework packet, on the back of the first page, you're given numbers 13 and 15 have that same problem. So here on number 13, it says QRS is equilateral. QR is 7 less than twice x. So that would lead me to believe that QR is equal to 2x minus 7. Okay. RS is 61 less than 5x. Right? So this is RS is equal to 61 less than 5x. So 5x minus 61, like that. Okay? And then 11 more than x. You get the idea? Now, one thing to remember on your homework is if you're told that something is an isosceles triangle, like you are in number 14, all right, you need to pay attention to which sides are congruent to each other, because those are the two equations you're going to set equal to each other. So in this one, CD is congruent to DE. So CD is 9x minus 25 and DE is 6x plus 8. You need to set these two equations equal to one another, solve for x, and plug those measurements back in to these little equations to find the length of each side. Okay? So tomorrow we will continue the discussion of congruent triangles by getting into the triangle angle sum theorem and the exterior angle theorem. So more shapes coming up. Really appreciate your attention today.